A very good afternoon and warm welcome to everyone joining our Masterclass series on emerging technologies, new frontiers in privacy engineering. Organized under the aegis of India-Israel Forum and jointly convened by the Ananta Aspen Center, Confederation of Indian Industry, and Tel Aviv University. This series is an initiative to promote academic linkages between India and Israel by enhancing technical knowledge and awareness about emerging technologies amongst college students in India. This series is possible thanks to the generous support of Triveni Turbine Limited. This is the third edition of the series. Another masterclass is planned in March, and we look forward to your participation in that as well. We are delighted to have Dr. Eran To, head of the undergraduate program, Department of Industrial Engineering at Tel Aviv University, join us today. He is the co-director of the Interacting with Technology Lab, which is currently working on usable privacy and security and human-AI interaction. Recently, Dr. To was also a visiting associate professor at Cornell Tech University. A very warm welcome to you, Doctor. We are happy to have you with us today and do this masterclass. We will begin with a 45-minute presentation by Dr. To, followed by the Q&A round. I would request all of you to please send in your questions throughout the session and do not wait until the end. We will be taking up your questions during the second half of the session. If you're watching the session on Zoom, please use the Q&A portal at the bottom of your screen. And if you're on Facebook, please write your questions in the comments section. It is my pleasure to now invite Dr. To start. Thank you.
So, hi, everybody, and thank you so much for inviting me to this really prestigious forum. I'm very happy to meet and talk with you virtually from Israel. Let me just share my presentation, and then we can start. Okay, so I hope everybody can see this. Let me just move things around here. Okay, so let me just briefly kind of reintroduce myself. As part of being the co-director of the IWIT Lab, my excellent students are doing, I think, really groundbreaking research on privacy engineering. So I'm going to present a couple of the works that students here, like Frank and Shrat and Tamir, were doing in the last couple of years. If you're interested, you're welcome to check the website of the lab. And a good place to kind of keep in touch with what the lab is doing is through Twitter, and the handle is Aranpi. So this, my lecture today is about something that's becoming increasingly complex and increasingly difficult for software engineers, for companies that doing software, for organizations that running software. And this is to embed social values in software and hardware products. Just give you some examples. Do you remember Google Glasses? There was a big buzz about them a couple of years ago, and then they were canceled and kind of went away. And one of the reasons is that people around people wearing Google Glasses were not liking the technology very much, because they didn't know whether they are being recorded through video or some face recognition thing running in the background. And apparently, Google engineers didn't really take into account how social values like privacy, social values that are important to people around the user would actually work. So this is an example of what happens if you don't think about important social values in your system. Another example is the controversy around Facebook recently. That's the reason that Facebook has changed its name to Meta. So because of a product manager in Facebook, Frances Hogan, who went on the record and in the US in the congressional hearing to talk about Facebook's problematic data protection methods or problematic privacy processes, and is now Facebook is in a investigation of several big US processes. Okay, so thinking about social values is becoming increasingly important, and today I'm going to focus on one social value, on privacy, and I'm going to first of all just introduce the idea of privacy. What do we talk about when we talk about privacy in a more way, and then I'm going to talk about privacy engineering, what it is, and just kind of give you a toolbox of privacy engineering methods, what you can do as a software engineer, as someone who is part of the software engineering process to provide better privacy to your users. So let's just talk about privacy. So what is privacy? We use the word a lot, but when researchers and academics have started to look at the concept in the last couple of decades, we have a more nuanced idea of it. So first of all, when we look at privacy, it's rooted in our psychology. It's a deep, basic psychological need. I don't know if anyone here has small kids, but my kids from a very small age knew that when they move into this phase when they want to be alone, when they understand that they have a room, they have their stuff. So it's a very basic, very deep psychological need, and it's a very important one. It allows us to experiment. It allows us to change because we can just keep in secret some of the stuff that we've done, for example, in college or when we were kids. So it's a very important psychological needs. It is also a very important social idea. So, if the whole idea of intimacy is based about having some privacy from some people, people who are in close contact with us know more about us than people who have less contact with us. Yeah, and from a social point of view, it's a very fundamental concept in every society. It's critical for our ability to present ourselves. It's critical for our ability to construct our identity. And it's a very ancient concept. So one of the things that I really love about giving talks in different countries is to go into the history and to see if I can get some cultural or historical evidence of privacy in very ancient times. So before this talk, I went into a little bit into the Indian methodology and history, and found that, for example, in the Mahabharata, Draupadi is the wife of the 5 Pandavas, and to kind of maintain this relationship, we need some ability to have private places and private moments, and there's some nice ideas and processes there on how to provide this kind of privacy. And when we look at ancient laws and ancient texts from all over the world, from the Hebrew text, for example, in Israel, from the Jewish texts from 3,000 or 2,000 years ago, from the Roman law in 2,000 years ago, and from many, many places around the world. In all of these cultures, there are ideas of privacy built into the very basic and very ancient laws and traditions. But privacy is moving fast, and right now, all over the world, we see lots of privacy legislations that try to take these ideas and create laws around them. So Europe is leading the way, I think, in privacy today with the GDPR, the General Data Protection Regulation, all over Europe, which is being used as kind of a canvas for other privacy laws, for example, the CCPA in California, the data security law in China, and also in India, there's a bill. I don't know a lot about it, but I've read a little bit. There's a personal data protection bill, and I think it's in the legislation processes in India. It introduces the idea of privacy by design. So when companies and government organizations want to create new systems, they need to design the systems according to some privacy processes. They need to ask for consent from people when they want to process the data or have some special circumstances to do so. And there are many, in the Personal Data Protection Bill, there are many mechanisms to make sure that these privacy principles are being kept. For example, that data protection officers that are assigned to companies above a certain size or to government offices. And these are special people who have the background and the ability to make sure that the company and the systems it produces really protect the customers or the citizens' privacy. Here is an example from Europe, but we have examples from other places where companies need to adhere to strict regulation. And for example, when Google didn't do something according to the European law, it was asked to pay 170 million fine, which isn't a lot of money for Google, but it still requires it to change the way it works. So how do we actually bring privacy to our users? And I'm talking here from the point of view of a software engineer. We need to think about privacy engineering. We need to think about ways to embed privacy in the systems we create. Privacy engineering is an emergent discipline within software engineering, and it requires us to think about our users, also people around the users, because people who are affected by our systems are not necessarily customers or users. And this discipline is driven by law. So we need to have privacy embedded in many systems that we create because we want to sell it in Europe, we want to sell it in India, we want it to adhere to the law. It's also driven by normative approaches. So software engineers, are connected, and there are some normative level of what is a good software, what's a bad software, and of course some commercial interest, like in Google Glasses. You don't want to have a system that users don't want to use because it violates their privacy. What privacy engineering includes? So it includes many processes that I'm not going to talk about all of them, but for example, things like privacy impact assessment, which is a process where you do at the beginning of the system development, you do some assessment of what is the effect on people's privacy. You need to study the user's privacy preferences. You need to develop processes that enhance privacy. For example, there are some software coding environments that help you make better privacy decisions. And you need to design many aspects of the system to maximize privacy. So I'm going to give some examples of these things here. Some research that my lab is doing shows us that, for example, the way that you do your user research at the beginning of the system development is really important. So, for example, we've compared asking people about privacy. So we asked the general public, and we also asked some software engineers, and we actually show that who we ask and the way we ask them is important. If we present the information about the system using scenarios, using personas, using things that methods coming from the user experience, actually people have better understanding, and they have better ability to judge if the feature of the system, for example, is appropriate or not. And if we only show them, for example, data flows, if we only talk about the data, then they don't have the ability to do that. So when we think about what can we do as engineers to protect people's privacy, there are two different approaches that we can take. One is policy-based, and the other is based. A policy-based approach is an approach where we protect through some policies, through the way our software interacts with the user, through rules and things like that. And basically, as long as these policies are kept, then the user privacy is kept. An architecture-based solution is way stronger. It actually protects through the basic technologies that we use, and we can't harm the people's privacy, even if we try to, unless the technology really fails. So when we think about Privacy Toolbox and privacy solutions, then we can put them on a scale ranging from policy-based to architecture-based. And the more we move into the architecture-based, then we can give them better privacy guarantees to their privacy. So, for example, giving users notice is policy-based. That's a very simple solution. It doesn't provide a lot of guarantee, but it provides some. If we give them better choice of what to do with their data, then it moves more into the architecture base. It provides better guarantees, but still less than other things. Then we have access and recourse to let them know what's happening with their data and give them the ability for recourse, for example, to delete their data. And at the end, we have data minimization. In data minimization, we minimize the amount of data that we gather, the amount of data that we process. And of course, that provides a high guarantee of privacy because we can't harm the privacy if we don't have the data. So I'm going to now basically go over each of these solutions. I'm going to give some examples from real life, and it's going to get more and more technical. So Notice is is in kind of the more design realm of solutions, while data minimization is much more technical, includes things like differential privacy and homomorphic encryption. And I'm going to talk a little bit about those things. And of course, as was said before, I would really love to hear your questions. So if you don't understand something, if you have some question, if you have objections, please put them in the Q&A or in the comment section so I can address them at the end of the talk. Okay. So let's start and talk about notice. What is a good notice? So you remember we used to get many of these kind of notice on our phones, whether to allow or not allow some apps access to our systems. And this is an example of a notice. It's a pretty problematic one. Why is it problematic? Because a good notice will allow the user to intelligently make a decision, and it takes into account the readability, whether the user can understand it, where we put it, the modality, and a good notice wouldn't interfere with the user's flow. It would be easy to understand, and we'll talk in the same language of the user. So let's just look at some examples. Here's an academic research that became very real very fast, where they designed some notices. For example, these privacy facts that show you about each app, what kind of information it takes. And actually, Apple recently implemented something very, very similar. And when we install an app on our phone, on our iPhone, like this one, then we have a list of all the information it collects, and it always allows us to go back and see it. There were a couple of interesting ideas on how to create good notices. So one of them is the privacy nutrition label, which is basically looking at privacy the same way we look at the ingredient list on food. In the US and in other countries, food manufacturers have a legal obligation to put the information. And the privacy nutrition label basically shows us what kind of information is collected, whether it's opt-out, which means that we don't have to give this information, we can opt out of giving it, or opt-in, which means that we need to make something active to allow it. Another example, HP, a very large company, makes printers, but also lots of other stuff, had developed in its Israeli research center a visual language for privacy notices. This is how it looks. It's for HP's enterprise software. So more and more companies are developing this kind of visual language for notices. If someone wants to hear some more, there's a great paper by Florian Schwab about looking at what kind of privacy notices there are and how we can categorize them. The place where we put the notice is extremely important. For example, Privacy Finder was an academic project in Carnegie Mellon University in the same lab that I was a postdoc in. And they basically embedded notices in a search engine showing the level of privacy of each website, showing that it actually had a very strong impact on the choices users had made. The timing of the notice is really important. One of the things that, one of the, I would say, problems that we have now with privacy notices is that they allow us to, they show us information right where we want to use the app and not in an ongoing way. And that actually changes the way we would make a decision about it. So how noticeable can we be? Privacy notices can be very noticeable. So this is just an example of, in Israel, there are some cameras on the road taking pictures of cars that drive too fast to give us a fine. And these are by law very noticeable. They are painted in orange so people can see them. But privacy notices can sometimes kind of be obstructed and you can hide it. So this is one of the examples of a good privacy engineering would make the notices very visible without harming the usability of the system. One of the main tools for privacy information is the privacy policy, which is kind of a very long legal document that many companies ask us to read. So, for example, Apple has those long privacy policies when we install a new operating system or something, or a new software or something like that. But studies have shown that most people, of course, don't read them. They just go at the end and click OK, and don't really read them. But we need to think about notices not only as an individual process, but as a social process. So sometimes it's not really important that people, that I would read every privacy notice, but if someone else reads them, if an academic or a lawyer reads them, then they can go and sue the company. So when we think about notices, they don't just give information to each user, but they provide some information to the whole society. So to summarize this chapter, a privacy notice can be good or can be bad. It depends on the way we design them, and they differ by timing, the channel, where we show it, modality, and what kind of control they provide to the user. So that's a good time to get into the second and kind of the next level of privacy engineering, which is choice. And in choice, we basically provide the user with control over their information. And this is, of course, very fundamental. It's very important because meaningful control over information is the heart of privacy. So a good control over information will be discriminative, which means that it allows the user to discriminate between information that's important to them and information that's not important to them, easy to use, and of course, works out of the box. And one very simple test for how well the choice mechanism that we try to create is working is to imagine that the data actually belongs to the user, which in many cases is the right way to do things. So if data actually belongs to the user, can they effectively exercise their ownership? So that's a very nice test to check it. What is a good choice mechanism? So for example, a good example is actually a product from Amazon, the Echo Show 5, which is a smart speaker with a screen and a camera. And in the latest version, we actually provided this sort of button that hides the camera. And this is a very simple to use control. And I think a very good one because of a couple of reasons. First of all, it's very visible. It's orange, so if you close it, you know that it's closed. Because there's a physical cover over the camera, then the user actually knows that they have the control. We don't have to trust anybody to do that. And it's very accessible and to the user. So choices, we have them all over the internet right now. So for example, if you go on Facebook, then you can choose who to share your post with. And if you go on a mobile app, then you need to allow or don't allow access. When we have these mechanisms, then we can ask whether this choice is fair. So choices are actually made in the context of a choice architecture, which is the way economics thinks about decision-making. A choice architecture includes the way that people make decisions. So for example, what are the defaults? Whether the default is to share everything or the default is to share nothing. What is the number of choices? What is the ability of users to make choices? And when we look at some interfaces, we see that the choice isn't really fair. So this is an interface by Facebook from a couple of years ago. And we see that the user can choose between sharing things publicly with friends or in a custom. And not surprisingly, the default is to share everything on public. So we know that this actually nudges users into making certain decision. So nudging is a very kind of fashionable idea right now, which is kind of gently pushing users to make decisions. And we have some academic and now even some practical works showing that you can actually nudge users to make better privacy decisions if you give them more information, if you give them the right information at the right time, etc. One of the works that we've done in our lab, we actually created an algorithm that looks at privacy choices. So, for example, sharing information on Facebook or sharing information in other places. And it has access to statistics about the choices that people had made and can generate automatically and optimize the choice architecture, which provides the default and the number of choices according to the decisions of people, of other users of the system, and some other motives. Another work that our lab is working, and this is a project with several researchers from Singapore Management University, is to look at social choices. So here we developed a system that's built for older people, older adults, people over the age of 65. Many of those people don't have technical abilities or technical know-how to interact with systems. And here we actually allow their younger relatives, their family members and friends and people around them to help them and kind of carry some of the decisions for them. So to summarize, when we talk about choices, then we need to think about the choice architecture. How do they make decisions? What are the defaults? We can talk about nudging, so kind of pushing them to make better privacy, better data protection decisions. And again, as with the notice, we tend to think about decisions as an individual process, but actually there's a lot of social influence and norms and communities in which decisions are made. Okay. So the next level in privacy protection is access and recourse. What is access and recourse? The idea is that the privacy is a long-term relationship. So we start to use an app, we have lots of information there. Maintaining this relationship requires interfaces, requires systems in which we provide access to users, to their data and to their controls. Meaningful recourse is crucial. Recourse means that if there's a problem, if there's something that the user wants to change, we allow them to do that. And we have more and more privacy legislation that actually creates some rights to the information. For example, to see what kind of information is kept about me, to allow users to take the data, that's data portability, to take it and move it to some other company, to have some recourse if an AI, if some automated decision is made about me, to rectify the information, to delete it, and so on and so on. And we have some examples of systems that allow us to do that. For example, Google Dashboard is a very advanced interface that allows us to see all the information we have in Google, the locations that they have on us, all the information they have. I really suggest to you people at home to go into the Google dashboard, Google it, and see what kind of information Google has on us. It's sometimes very surprising. Google Takeout is another service by Google, and we have services like that from other companies that actually allows us to download and take the information from Google and then move it to some other companies. And there are more and more companies that actually build tools for managing ongoing consent, ongoing relationship with people's privacy. So this is a product from IBM, but I think it's a very interesting space for startups to innovate right now. So to summarize, access and recourse is part of the ongoing relationship between companies and the users based on the data. And we see lots of personal data centers and takeout systems that actually embed laws that provide the users with the ability to delete, know what's happening, and change their data. So the last category is data minimization. And the idea with data minimization is that if the best solution for privacy is actually not knowing about your user. Sometimes we need to know something, but many times companies just, collect lots of information. So laws today actually requires us to collect a minimal amount of information that's important to provide services. And of course, if we want to have some interesting application, then we can't not collect anything, but we can think about analyzing the minimal data requirements and to use some technologies to actually provide services without all the information. One very useful concept in understanding how do I minimize information is to look at very simple software architectures. For example, client server. So we have the client. The client is what we call the user sphere. So information in the client is managed by the user. It stays on the device of the user. And then we have the server, which is the information about all the users. And then we have the user data in something that's called the joint sphere. So the user data is, the conceptual idea of the data that the user and the server can interact on. And of course, client-server architectures are very problematic when it comes to privacy because they tend to access all the data from the clients and store it in a centralized place that the company has access to. But we see that there are more and more distributed architectures like the blockchain. And of course, the blockchain is just one example of distributed architecture that has lots of hype now. Actually, the blockchain isn't very good in protecting privacy, and it's also very inefficient ones, but I hope we'll see better architectures in the future where there isn't any one server that contains all the information, and that of course provides some power to the users. On the other hand, sometimes these distributed architectures like the blockchain are public, so we need to think about new ways to make the information private. One way is to look at encryption, and we see lots of encryption mechanisms that create an encrypted user sphere where the user has more power because the data is encrypted and only the user has the key. Architectures on the blockchain like Zero Cash, for example, use very sophisticated encryption mechanisms to do that on the blockchain. One example of these types of encrypted systems is contact tracing. So if you remember COVID, in many countries in COVID, I don't know about India, please let me know in the comments below. At the beginning of the pandemic, at least, there were systems that notifies us if we were in contact with someone who had COVID. And at the beginning of the pandemic, countries like Singapore developed centralized contact tracing, where all the information about people's whereabouts is in one place. But very quickly, Google and Apple had adopted a mechanism called DP3T, which uses a centralized server, but the centralized server only hosts encrypted information and doesn't really have access to the location, and all the analysis is made peer-to-peer. One of the ways that we implement data minimization is through mechanisms like differential privacy. So this is the basis, for example, of the way Apple collects information about app usage without harming people's privacy. It's a very simple idea. So imagine that we have Alice and Bob. We have two entities, and there's information, there's private information about Alice that she doesn't want to share with Bob, but Bob wants to have some statistical information about all the database to make some analysis or something, for example, to know which app is crushing. So the goal of differential privacy is that Bob will not learn anything new about an individual record in Alice's database that they didn't know already. How can we do that? One of the ways is to create noise. So in differential privacy, we add calibrated random noise using a set of functions and a set of distributions. So instead of giving the database with all the information, we add some noise to the database that provides some plausible deniability to the information. And in differential privacy, we actually calculate the minimum amount of noise that can be added without creating a problem for the utility of the information. So, for example, we calculate this kind of epsilon at the least amount of noise that we can add. So, in which way that if one record about a user is removed from the database, then Bob wouldn't see the difference between the two versions of the database. And of course, if Bob has several interactions with the database, for example, has several queries, we can add some additional noise to make sure that they still don't learn anything. So differential privacy is used in many systems now, but it still has lots of problems. You can imagine that if we add too much noise, or if we add some noise in a different way, or maybe in some applications, the amount of noise can be large enough so that we couldn't get some general information about the database as a whole. There's lots of research that goes into calibrating and finding the right amount of noise and the right amount of applications. Another method to serve people's, keep people's privacy is by using synthetic data. There are lots of startup and academic research about it. I'll just move forward here. So for example, work done in my lab by a master student called Maya Arditi had actually tried to create synthetic data for geospatial databases, which are databases that have information on people's whereabouts. She used several mechanisms, and the most efficient ones were based on LSTM. LSTM is a deep learning mechanism which has some ability to look at sequences of information, and here we use it to learn information about people's sequence of whereabouts. We used information coming from an Israeli cellular provider, and we were able to kind of create a sanitizer that models information in the database and then generate synthetic information, which is totally new, but it provides some of the features of the original information. So for example, here are the maps of Israel where people are coming from and going to, and we see that the LSTM map looks pretty similar to the original data. So this is the architecture that we created. We have the original diaries. They are basically a sequence of all the locations users were in, and we train the models and we test them and we evaluate them to create models that are very similar to the original diaries, but have the least amount of information about individual users. So these are the example of the diaries. So these are the days, and here we have the hour, and we see that people are at home, and then they're going to work, and then they drive, -1 is driving. And here we have the generated information in different ways. We see that some diaries look very similar, for example, based on the deep learning method, and some diaries look very, very different. That's based on other statistical methods. And then we compared, and we show that for certain very important applications like predicting travel or urban design, we can actually get very good results from the synthetic data. And there are more and more startups and companies that do exactly that. So Datomize is an Israeli startup that actually generates synthetic information, especially for healthcare, based on actual data, but without harming people's privacy. And there are specific solutions. For example, there's a company that can create synthetic faces for face recognition and for other applications that doesn't harm people's actual visual information. Okay, so that's my talk. Let me just summarize it very quickly. The first most important, takeout message that I have here is about privacy engineering. It's a new engineering methodology. I think, given the privacy legislations that we see all over the world, including in India and China, the US, and of course in Europe, privacy engineering is going to become very important. It's going to become one of the things that every engineer do, and we'll see that I hope that there will be a lot of demand for it. So I encourage all of you to think about privacy engineering as one of the engineering paradigms or disciplines that you can train in. It basically provides a toolbox of escalating solutions ranging from notice, very, very weak sort of solution to stronger solutions that that provide higher guarantees, minimizing the data using things like differential privacy to hide the information, but still use it in a meaningful way. And more generally, I think for everyone working in software engineering, for development of systems, we see that it's the connection between society's values, legal concept, and systems that we create is becoming more and more complex. Privacy is just one social value, but we have more, like fairness and equity and accessibility. And thinking about how to embed those values is really what I think it creates an edge for engineers in global organizations today. So thank you so much. That was my talk. I'm going to leave you here with the again with my website and my Twitter handle if you want to hear more, and I'll be glad to hear your questions. So thank you so much for listening.
Thank you so much, Dr. Doe, for that extremely interesting talk. I'm sure students have thoroughly enjoyed themselves as well. We'll now open the floor for questions. I think we already have a question or two in the Q&A box below. If you would like to take them.
So laws and regulations don't occur in vacuum, especially in areas like security and privacy. Could you elaborate more on the correlation? Yes, I hope I understand the question correctly, but of course, you know, every culture, every country has its own ideas of the social values that are really important to them. The kind of systems, for example, that we have here in Israel are different than the kind of systems that people in America have. So I'll just give an example. You know, society in Israel is kind of more family focused than society in the US. I don't do, even though I visited India, I was 4 months in India and I visited India a couple of times. I don't want to assume too much about your culture. So I'm not giving examples from India, but I'm sure that there are, you know, very similar examples. So for example, here in Israel, there are many apps that actually are created for families, and you wouldn't see that in the US. So of course, when we look at things like security and privacy, they really reflect the values of the country. What we see now, I think, in the world is that things are moving very fast. There's dynamics of the values, they change really fast, and they change in a very connected way. So if we look at the data protection bill in the Indian Parliament right now, it resembles parts of the GDPR. I think you see the influence from the GDPR, and if you look at the laws in the US, they also are, you know, they carry this kind of influence also from Europe. So, so this kind of dynamic, I think it's a very interesting one, and we see sometimes clashes. You know, when we import into a country a sort of law that comes from another country, then maybe it wouldn't stick, it wouldn't work so well. You know, the only thing I can say that is, you know, it's just an interesting time to live if you research privacy, because you see these really interesting things going on. Okay, another question. You told about a number of startups which are working in order to protect people's privacy, but can they stand against the hungry data giants? Well, that's a very good question. There's actually, in Israel alone, there are about 50 startups that work on privacy. I'm talking about startups that get money from venture capital. Israel is a very strong, has a very strong startup culture. Let me just close this phone for a second. I'm sorry, I'll be back in a second. Okay, I'm so sorry about this. I don't know if you can stand against them. Maybe the data giants will buy them. I think that's what some of the these startups are building on. But I do think that there's a chance here, because whenever the legal landscape changes, as we see now with the new privacy laws, then it creates ability for new startups and new ideas to become influential. And many of the older giants, like Facebook, for example, they move slower and they don't have focus on that. So I do hope that they will meet the success. How does data minimization prevent privacy and surveillance? So the idea of data minimization is that you collect as little as possible. So for example, if you don't collect information about people's faces, then you don't have a problem of, for example, surveilling people using facial recognition. So the idea is to only look at the minimal amount of information that you need, and that goes against some of the software engineering practices of collecting as much information as possible. So when I was a software engineer, I still I guide my students in developing systems, and sometimes when you're a software engineer, you say, okay, let's collect everything possible because we might need it in the future. But this goes against the idea of privacy, and it creates liabilities for companies. So data minimization, if used correctly, can improve privacy. And we see that if we look at synthetic data, if we look at differential privacy, then sometimes we can actually have applications running if we don't have, while not having none of the information about our participants, about our users. Okay, how could we draw or measure compliance with global data privacy regulation, as they are often loosely structured and interpreted in many ways? That's an excellent question, of course. Data regulation is, I think, your observation here is very correct. It's sometimes very loosely structured, and sometimes it's loosely structured because the legislation doesn't want to look at a particular technology, but have some general definition that would be useful for many types of technologies. I think what we're going to see is an interesting dynamic, and we see it already in Europe. So first of all, people can sue companies if they think that they collect too much information or they harm their privacy. And this method of suing actually provides an incentive for companies to not collect information. So that's one mechanism that works pretty well. Also, the idea of data protection officers, that we see it also in the Indian bill, works pretty well. It actually worked very well in Europe and in the US. If you have a data protection officer in the organization, and this person becomes the hub for expertise about privacy, then we see that companies just change their ways because they now have someone to consult. The data protection officer, many ways, in many times, reports directly to the CEO or to the general counsel, which means that they have lots of freedom. And these kinds of organizational processes can sometimes help in actually making sure that the interpretation is careful. It's based on the users and what they expect, and it's not general or non-existent. Okay, I think I've answered all the questions in the Q&A.
I think there's one more question, Professor.
How does Bitcoin protect privacy? So Bitcoin is a very problematic mechanism because the privacy protection in the basic blockchain. So Bitcoin is based on the blockchain, and Bitcoin is a currency. But when we talk about privacy, we need to look at the blockchain and the general ledger that stores Bitcoin transactions. And originally, Bitcoin transactions were pretty public. The only thing that was private was the fact that you didn't have your name, you had just, an identifier. The problem is that the identifier can actually be traced back, for example, where you exchanged money for Bitcoin or things like that. And we have lots of research and some examples of the way that the current Bitcoin blockchain doesn't provide very good privacy guarantees. So Bitcoin is a bit problematic, but we have kind of improved blockchain. So you're welcome to Google Zero Cash, which is similar a distributed currency. I'm not going to call it cryptocurrency because it's not even encrypted. I don't know why it's called crypto, but it uses things like homomorphic encryption and things like that to give better protection on users' identity while still keeping some of the interesting abilities to make sure that a transaction really happened and things like that the blockchain does provide. Okay, can federated learning and edge computing be combined? There's actually some interesting research about it. So I'll just interpret the question a bit. Federated learning is this idea that you can create a model in machine learning which is distributed, so it's not concentrated on one computer, and that of course provides some privacy because the information is distributed. And edge computing, I would say, I'm interpreting it in a very kind of very free way, is a way to run processes on the large-scale cloud, and the again, edge means that the cloud isn't centralized, and it can happen. It can work on small devices and ubiquitous computing. So there are some studies, I don't know them too well, to be honest, that try to combine the two, because you need algorithms that are able to create a system that can exchange information really fast, because it takes time to look at all the edge nodes. So I think it can be combined, but we're going to have to pay some price in the and how well the model is built, the performance of the model, especially the time it takes to learn the model. Okay.
Thank you, Professor. Thank you for that talk. That surely was very fascinating. And thank you all for your questions. Regarding the recording, it will be uploaded on our YouTube channel under Ananta Aspen Center. With that, thank you again, Dr. Toh, for joining us today and for such an informative session.
Thank you so much. And thank you for the real, I think, intelligent questions. And it's a pity that I'm not there in person and can see you and interact with you. It's really hard to talk to your own computer, but I'm really happy you were able to join me. So thank you so much for listening and for asking questions.
Thank you.